What's up, Chuckles? This is Mr. Schneider coming to you again. I tried to do the first video for example 2, but it crashed. So here's take 2 coming right at you. So by now you should have watched Dr. Ashley's video. She does a great job. She does it in the way that we do it in class using p-values and level significance. She has a sweet flow chart. At the end of that, hopefully you took note. That's something that you might want to use. As we get kind of confused on the wording of our conclusions sometimes. So that's a great little tool that she has for you. But I am going to come back to you. Hopefully I can kind of explain some things maybe she talks about that you don't understand and all that. But we're going to do example 2. I'll send you on your way with your homework for the week, and then we'll be good to go. So reading through this, the legislator wants to determine whether the performance rating has changed from last year to this year. The table shows the ratings from the same 16 people. That's why it's paired data. It's the same 16 people, and then they've noticed her performance, and then they've rated her in a different way. So we want to know, is it statistically significantly changed from last year? So she doesn't say, or the person doesn't say they want to know if the scores improved or went down. So it just says, have they changed? So our null and alternative hypothesis are going to be, let me see, this is where it, oh no, good. It's going to be, it is our null hypothesis, blah, 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 is going to be mu d sub d. Now, that might be something where, oh, that's terrible. It's a terrible mu sub d. That might be something where, and that's not an n, it looks like an m, that's a mu. The mu sub d is basically the mean of the differences, okay? You saw in Dr. Ashley's videos that the differences of these two sets is really what we're looking at here as statistically different or not. So that's mu sub d, the mean of the differences. So did they stay the same? Are the differences, so if the differences are 0, all the values stayed the same. That's just simple math, right? 1 minus 1 equals 0. The number didn't change. If they change, then the mean of the differences is not going to be equal to 0, which is going to be our claim here. Okay. Good. All right, so the next thing we need is our p-value. And then we need to compare it to the level of significance, which is 0.01 right here in our problem. All right, so what we need to do, and I might pause this while I input it to the calculator, is I need to put, let me see. I need to edit and put all of these values into L1 and L2. Then we'll use L3 to get our list of differences, okay? So I'm going to pause it while I do that. All right, so I'm back, and just like magic, L1 and L2 are populated with our voter ratings from last year to this year. So what we need to do here is I need to come up here, and I need to enter in, I need to do L1 minus L2. So you can roll that back if you don't know what I'm talking about. If I hit enter, it should automatically populate with the differences there. So that's going to be key for us. Okay. What we need to do for our next step is we need that L3 populated, our list 3 populated with the differences there. So what I'm going to do here is I need to get out of this. I need to come back over here, stat, tests. Now I'm not going to do toSample because I'm just running the t-test on that third column, on the differences. So I'm going to do the t-test. And I'm going to take it from data, okay? And I'm getting the little guy here. It says that we will be cutting off the recording. So I will see you in just a moment when we start up our next one at the same place. Thanks. Bye.